Good morning to all once again in this digital conference on innovations in maritime technology. I am Dr. Suhas from our class. Is going to talk on applications of digitalization and alternative fuels for decarbonizing of shipping. Uh, First of all, actually, when we talk about the decarbonizing, uh, we have only two options. Either you reduce the quantity of the fuel or reduce the content of carbon in the fuel. That's what the alternative fuel is. So both of these things actually we will just look in now from here onwards. So I will be starting with the IMO's target through their GHG reduction strategy, the upcoming environmental compliances for ships EXI, CII, and then we'll move on to the digitalization applications to comply these upcoming environmental requirements, and then alternative fuels. And we'll talk about on our collaborative projects wherein IRIS is involved with the industry, and we'll conclude this session after that. So IMO has taken a significant step to combat climate change in its 72nd session of MEPC in April 2018, wide resolution MEPC 304, and adopted initial strategy for reduction of greenhouse gas emissions from international shipping. So I deduced this strategy into four objectives, such as to reduce the carbon intensity of the ship through implementation of further phases of the energy efficiency index EDI for new ships, reduce the CO2 emissions per transport work at least 40% by 2030 and 70% by 2050 compared to 2008 as a base year, and then reduce the total annual GHG emissions by at least 50% by 2050 again compared with the base 2008 year. Ultimately, to achieve zero GHG emissions as soon as possible within the century by 2100. Okay, so here IMO will achieve these ambitions by applying pre-existing energy efficiency measures as well as new measures such as EXI and CII. MEPC 75 adopted amendments pertaining to phase 3 timelines and reduction rates pertaining to required EI, that is the pre-existing energy efficiency measure, and the new measures EXI, which is a technical measure, CII is a operational measure adopted in MEPC 76. And definitely the discussion on alternative fuels is also going on. All these are basically the short-term and medium targets over here. What I tell you here that technological innovation and the alternative fuels for international shipping will be integral to achieve the overall ambition. It cannot be, this ambition cannot be achieved either by only going with the technological innovation or only with the alternative. There has to be a combination of both. We know this three-step approach taken by IMO over here. Like it started with the data collection system, DCS, in 2019. The data analysis is also been done over with the data, and further decision making will be collection and data analysis phase. So decision making will be undertaken by the end of 2026. Moving forward, I will just touch upon EXI requirement. This is a technical measure of ship's energy efficiency, and regulation 23 and 25 of MARPOL Annex 6 are applicable from 1st January 2023 for ships of 400 GT and above which are engaged in the international voyage. What is happening over here is for each ship, it has to attain EXI, and required EXI values are to be calculated and compared, and it is expected that it is required that attained EXI should be less than or equal to required EXI. If it meets, well and good, fine. But if you don't meet, then the ship has to undertake some energy efficiency measurements. In all, again, this is a technical index and there are no measured values of previous year and no onboard measurements are required. So briefly, EXI only refers to the ship's design. But unlike EXI, CII is an operational measure of ship's energy efficiency, and regulation 26.3.1 and 28 of MARPOL Annex 6 are applicable from 1st January 2023 for ships 5000 GT and above. Basically, this is the extension of existing requirement of IMO data collection system. So wherein the data verified under IMO DCS will be used to calculate attained annual operational CI, and which should be less than or equal to required annual operational CI. So this required annual operational CI is calculated based on the base year of 2019 data collected. So over here, the main thing is to be seen that the required annual operational CI will be reduced every year after 2023 by 2%, and there will be new required CI value for each ship going forward. At the end of the 2026, this analysis will be considered again for the further decision making. I will continue with CII and now talk on the CI rating. So once we have the value of attained annual CI, the vessel will be assigned with a ranking label among the 5 grades A, B, C, D, E. Respectively, they will be as major superior, minor superior, moderate, minor inferior, and inferior. So it is expected that the vessel should be rated as A, B, A or B or C. Midpoint of the C is basically the required CI value. So if the vessel's attained CI value is 9, then it will be assigned rating B. So it is not good for any vessel to be rated as D and E. So what actually here is the important is thing that the vessel needs to monitor its fuel consumption data very closely, very accurately, so that they will not overshoot in the rating scale. After the CII, there are going to be amendments in the SIMP and SIMP Part 3 is now going to come, which include mandatory content such as methodology for data collection and calculation of attained CII. 3-year implementation plan on how the required CII will be achieved, effectiveness of measures implemented, followed with self-evaluation and assessment, and this is subject to approval. So we can understand here, see, this data which is required for calculation of attained annual CII is to be monitored as accurately as possible so that there will be a minimum value of attained CII. This SIMP Part 3 mandatory requirement is applicable for all ships irrespective of their rating. But for ships that achieve a D rating for 3 consecutive years or an E rating for 1 year, a corrective action plan shall be developed as a part of the SIMP Part 3 and subject to approval. So this entire thing, what actually is going to be coming as requirement under SIMP Part 3 and CI rating, this is possible by utilizing digital technologies, that is digitalization, without involving human interference, because we need as accurate as possible these values of fuel consumption. So this I just stressing over wherein the digitalization is going to help us in achieving the compliances. A brief on the digitalization definitions I will start with. It starts always with the collection of data in the form of digitized way, and use of advanced digital technologies to increase efficiency of existing activities or to enable new activities including decision making. In short, ship generating more than 2 GB data on a daily basis when at sea, and this data should be used for making decisions. So in the context of decarbonization, we require monitoring of data, measurement of data, and that can be possible either by connecting sensors which are collecting the data and connect to cloud and supplying this data for further analytics, where machine learning techniques can be used to identify patterns in the data and develop models for prediction and creating alerts or alarms going forward. Digitalization and decarbonization are mega trends that will enable shipping industry to undergo structural operational changes and seen as a driver of sustainability. One thing I want to again tell over here is that digital has the potential to provide IMO with the data and information to develop global standards, that's new regulatory approaches, implement it and evaluation of the same. This practice or this way process of using digital data and making data driven decisions are going to be a new normal in shipping industry in future. It's started now, but it's going to be new normal going forward. So I have come to now this digital platform, which is actually a joint partnership, joint collaboration between IR class and Smart Ship Hub. So wherein the expertise of IR class as a classification society are merged with the digital transformation capabilities and expertise of Smart Ship Hub. So this is a multi-tenant on-demand digital platform and one-stop solution provider to ship owners to customize as per their specific requirements, to collaboratively grow digitalization, and to offer best-in-class solutions for the maritime community. So here, as started my discussion with the IMO strategy ambition levels, then the requirements of CII and what is need to be done to comply with the CII requirements. And then we came to the digitalization. Now we are saying the IRS is now providing this facility, this digital platform for the users of research by the ship owners, helping them to meet the environmental compliances towards decarbonizing of shipping industry. This platform is having multiple facilities, right from data collection, use of sensors, and the data screening, filtering, until the predictive analytics. However, we are only going to see its applications for the decarbonization, right? So these are the some applications of our digital platform, which are emission monitoring and analysis of energy efficiency, which will include environmental performance of ships, then compliance checks as per the goals, emission monitoring and analysis, and compliance to CI. CI we are still working on, but I want to stress it that over here. Then fuel optimization is possible over here, obviously by fuel monitoring, that to real-time consumption, and the comparison with between noon report and actual consumption can be made over here. Ultimately, what we are going to do here is monitoring the overall vessel performance and analysis by considering the past historical data and trends and applying the data analytics techniques such as machine learning and artificial intelligence to this data. So this is our first dashboard looks like for the remote monitoring. So over here, the red dot is basically the vessel's position. The red line is the suggested path based on our analytics outcome. The black line is the suggested path based on our analytics platform, and the red line is the path taken by the vessel. So we see that over here, though, if our path, if vessel undertakes during its voyage, there can be around 10 to 12% of saving in the fuel consumption. So this dashboard shows over here in the left corner the fuel quantity consumed by the main engine, auxiliary engine, along with the CO2 emissions, SOx emission, NOx emission, and any other consumption by such as like boiler over here. It has other capabilities also, like parameters of engines are shown over here and some others. At the same time, alarms and alerts are also shown over the right side. So we'll just see further. Now the next dashboard picture is the voyage to voyage fuel consumption monitoring and CO2 monitoring. So we have the inputs on the departure port data, arrival port, and how much the cargo is taken at sea, and we come to the some graphical representation in terms of the bar graphs over here for the fuel consumption, and the same is again plotted over here in different units like nautical mile per nautical mile, that's transport work, then CO2 consumptions over here, and the time spent at sea and time spent at berth. So this is the fuel and emission monitoring per voyage basis. We can compare both known and actual fuel consumption values for any vessel. So if you see over here, the red line is basically the actual fuel consumption experienced by the vessel that is determined by our analytics tools, and the other one, the bluish, slightly bluish bars are the fuel consumption reported as per the known reports, and the yellow boxes are the basically the differences in the actual fuel consumption and the known reported values. So, and this is possible to do on daily basis for any ship. So this is how, means we can understand at sitting at shore office also whether the known the values of fuel consumption reported in the known report are really correct or there is any deviation, and further decisions can be made over. Trend analysis based on the past historical data of the vessel for any given period, we can define the graphs for fuel consumption with respect to the shaft RPM and with respect to vessel speed for any given shaft RPM or speed range that we can do here. So here, if on the right hand side graph, if you see there is upper limit set for this vessel is 800 kg per hour fuel consumption. That is the set upper limit, and we have the actual trend line over here of the fuel consumption for different ship speeds over here. So this upper limit, upper threshold is being used in creation of alarms and alerts if the vessel is approaching this upper limit. This is how the vessel can contain or limit its fuel consumption during its voyage, and so that the overall fuel consumption will be lesser and CO2 emitted will be lesser, and that's how it can meet the set CI value. This dashboard picture shows the list of alarms and alerts. There could be like based on the time and date, there will become some alarm message. This is like pre-filled message over here, and this alarm is related to which part of the system, that also is being over here. If we see one of the alert system, it will be having a description of the alert, what is the possible advisory can be given on board, the causes of this alert, and action to be taken. These are the suggested actions taken. This alarm is created against which threshold. These thresholds are preset for each parameter. This is the entire dashboard shows the fleet performance. The red dots are basically the fleet of any company over here. So sitting at the shore office, it's possible to monitor where the vessel is and what is its parameters. So down below you can see there are like each box is for per ship, and if you click that one, then you will get to know the details of that particular vessel and its location and further information on its fuel consumption. Right? Okay. Yeah. And if the vessel, the company is having the sister vessels or the vessels which are operating on a particular similar kind of route, then also it is possible for the company to compare their fuel consumption for the specific period on daily basis. So here we can see that one or two vessels fuel consumption is compared over here on daily basis. Someday the vessels, one particular vessel's consumption is lower than the other, and other is having more than that. But at the end, when we see the bar graphs on daily basis for the fuel consumption, we can clearly understand which vessel is consuming more fuel, though they are operating on the same route, they are of sister vessel characteristics. At the end of any month or any set period by the company, they can see how much fuel is consumed and how much the expenditure is incurred over the fuel consumption for the comparison purpose. So this is how one of the commercial application of the digital platform can be utilized over here. Right. So this is up to this point, I have discussed the digitalization applications over here. This there can be more we can talk it about, but given the limitation of the time, I am not actually going in more in detail of each of these slides, but definitely we can discuss those on one-to-one basis. Henceforth, I just move to the alternative fuels. One thing is over here that the IMO GHG targets may not be met without alternative fuels, as I said earlier, and the energy sources that offer deep GHG emission savings compared to current fossil fuels. So these alternative fuels, each of these alternative fuels are different possible CO2 emission reductions. However, the studies reveal that no such alternative fuel exists currently that can cater to both problems, the problems of reduction in environmental impact as well as compliance with the current environmental regulation. No one solution is available. For example, if you take LNG, which is a great option to comply with existing regulations, but it emits greenhouse gas as well as in the form of methane slip. Also, the tank sizes are almost 3 to 4 times higher, and thus it increases the cost of a new vessel up to 30%. So in a nutshell, what I want to tell over here, going forward to the selection of alternative fuels, we need to consider some of key aspects, and these key aspects are production processes, sources, and technology, well-to-wake emissions, total impact from the production to the end use. We'll say well-to-wake emissions, right? Energy density, how much energy a fuel contains for a given volume of weight. Drop-in fuels, which can be directly used in the existing engines. Technology readiness, that is technology advancement and maturity for uptake in marine industry. Hazards, risk in storage and use on board needs to be assessed, and at the end, life cycle costs. So these are some of the key aspects which we have understood while working on alternative fuels. At the same time, there is other aspect like the target wherein these alternative fuels are going to be used, whether on ocean-going vessels, short sea ships, or inland or domestic markets. So these are the key aspects when we select the alternative fuels. IRS has already started in 2 years back by developing its rules and guidelines to support the industry implementation. So we have developed so far gas fuel vessels for seagoing vessels. We have classification notes on natural gas fuel vessels for coastal and inland waterways, guidelines on methyl fuel vessels, guidelines on vessels with fuel cell power installations, guidelines on high voltage shore connection systems for ships. These are for the shore supply connections for vessels when they reduce the emissions when they are at the port. And we have guidelines on battery powered vessels also. So this is also for preparation, and there are going to be more coming in line in future time also. We are involved with industry in some of the collaborative projects on alternative fuels. So our first project is the biofuel trials on coastal vessels, wherein the aim is to reduce GHG emissions of coastal vessels by the use of biofuel trends. And IRS has been involved in witnessing and verification of initial trials, measurements of emissions, as well as full examination of engines after a trial period of 3 months under all sea conditions at both loaded and ballast passages. Here, FAME, fatty acid methyl ester, is used as a fuel, which is biodiesel, and obtained by from filtered soya extract. And this is blended with low sulfur high speed diesel, LSHSD. So there is a 20% blend of biodiesel with the 80% of LSHSD, and we call it as a B20 blend. The pure biodiesel B100 samples are tested to meet the criteria mentioned as per the ASTM D6751 standard. So there are 2 vessels over here in this project, and these are the main engine and auxiliary engine parameters over here. So ship 2 is basically the build before 1993, wherein the requirements of SOx are not applicable, but for ship 1, SOx requirements were applicable. So what is our observation over here is the CO2 emissions are found reduced by approximately 7%, on average 7%, while running on blend fuel oil. And vessels using blend of VLSFO, residual marine fuel, with biofuel on their international going ships. This is another project which we are going to start now. Overall, here the challenges are in terms of the sustainability, availability, and commercial viability. It depends on vessel to vessel from where the fuel is made available, and if there are any changes to engine to be made, that OEM's consent and confirmation. Our second project is on retrofit and conversion to LNG and CNG fuels. So here, what is done over here, that retrofit of engines is undertaken to be operated on dual fuel for inland water and coastal vessels, wherein the use of LNG and CNG as a fuel is made. We are working on 55-meter Ro-Ro ferry conversion to LNG fuel, and this retrofitting is underway as per the requirements of IRS classification notes for natural gas fuel vessels for inland and coastal service. So far, the things are fine in this project. We are on the positive note, but right now we cannot disclose more than this. But at the same time, we have another project, retrofit or conversion to fuel CNG fuel as a dual fuel option for inland water barges. There is a huge demand for these kind of vessels, barges and coastal vessels. The third project is on fuel cells. IRS has extended its technical expertise to a yard to develop indigenized hydrogen fuel cell technology, wherein actually end-to-end solutions, system or component compliance in marine certification approval in principle, rule development and validation in technology are the areas wherein actually IRS is supporting this shipyard towards the new development on fuel cells. We are working on battery propulsion, basically the certification of lithium-ion batteries for the marine industry use. So far, the works visit is completed, and some of the type tests of the batteries are ongoing, and soon they will be completed also. We are also working on certification of vessel with hybrid propulsion and solar-powered vessels with lithium-ion battery storage. So this is so far what we are doing on alternative fuels, right? So, but any even if we are selecting any alternative fuel for the as a fuel for the vessels voyages, at the end we need to take a decision whether this is viable or not, whether the alternative fuel adopted is effective or not. And then again things will come to the digitalization, wherein we require data from the ships, daily operations, how much fuel it has consumed, even if it uses the alternative fuels, and further decisions are to be made on effectiveness of alternative fuels after using the data, after doing the analytics on the data. So in a conclusion slide, what I want to tell here is that the importance of digitalization and alternative fuel is discussed towards the compliance of upcoming environmental requirements for ships. So rather than EXI, the more focus is on the CII, which is the Operational Energy Efficiency Index, right? So the data, the fuel consumption data, which is consumed by the ship for its daily voyage operations, will be taken into consideration going forward, wherein CII rating will be assigned to the ship. So in brief, CII is to be more focused than EXI, since EXI is a design concept and maybe one time process. New normal of digitalization needs to be adopted with changing landscape, digital connectivity, data and analytics skills. So here actually the thing is that every shipping company may not adopt this digitalization landscape by its own, because it requires some setup, some infrastructure, some skills, and every company may not be adequately positioned to utilize this digitalization technology. So in this case, there has to be a collaborative approach. Just like I introduced you, IR class and SSH digital platform. So this can be utilized over here for collaborative approach, and that's the best practice what I see to grab the opportunity of digitalization, rather than spending, because spending is another aspect to adopt the digitalization. Again, I just repeat over here that for effectiveness of evaluation of alternative fuels, digitalization again has to be in picture in a collaborative manner. Biofuels, we have seen as our experience out of this, make more, competitive, looks more competitive than the conventional fossil fuels. However, biofuels have challenges in terms of sustainability, availability, and commercial viability. It depends on ship to ship and as per the purpose wherein it is used. Still, there are some issues related with storage, transportation, safety, toxicity, and cost of alternative. This needs to be looked into, and I hope in the coming days, these issues also will get sorted out. At the end, I will stress on there is a need to shift to use the digital technology as necessary for achieving IMO GHG targets by the set timeline. So going back to my first statement, beginning at the this presentation, that either we have to reduce the fuel or we have to use a fuel which has less carbon content to emit less CO2 and which can be useful for achieving the GHG targets, IMO GHG target. So with this, I conclude my presentation and I thank you all of the audiences. Thank you very much.
Thank you, Dr. Suhas. Wow, that was an amazing way to begin the conference. In a nutshell, you've kind of captured three of the hottest topics today: the greenhouse gas emissions, data monitoring and management, and alternative fuels. There are a few questions that are already come up. A small request to our audience: could you please address your questions in the Q&A section so that it's easier for us to review and share with the presenter so that we can get a quick response. We have a few minutes, so I'm going to be fairly quick. My first question is that 2 GB of data that we are talking about on a day-to-day basis from ships to the office, are we geared for this? Do our satellite networks have the capacity to do it now, or are you envisioning this to happen over a period of time?
Yeah, definitely. Actually, ship is generating a lot of data from 2 GB to 4 GB. And, only it doesn't require high speed actually. 128 kbps or up to 512 kbps speed is enough to transmit this data to the cloud. But it again depends on the scope of the data telemetry. What data is required to be transmitted? How much data is means whether the scope is only decarbonization or the scope is something else also, like machinery predictive analysis also. It depends at the end, what is the scope of the digitalization?
Yeah. Okay, thanks. There is another question on the smart ship hub. Is this a common platform, as in, or is it, and will it be a subscription kind of mode and only linked with IRS, or is this going to be available across to owners for vessels that are non-IRS classed as well?
This is on-demand platform, and we have 2 different subscription schemes. Like the first one is CapEx plus OpEx, wherein the ship owner has to pay some initial lump sum, little bit larger amount as installation charges, and there will be monthly subscription as a OpEx. In our second option, we have only OpEx. So there will be like a little bit longer period, and wherein the owner will be paying on monthly basis. So we have these 2 subscription, and this is not only for IRS. This can be used by anybody. That means IRS as class, owners, even insurers and yards also. This is actually the common platform. The applications and the usage depends upon the stakeholders' interest.
All right. Okay. One more question related to this is, what is the typical ROI for an LR2 vessel, and do you have machine learning and AI tools embedded in this platform to get predictive analytics?
Yes, yes. We have embedded the analytics tools in this platform. But we start actually with obtaining the historical data from the ship, at least for last 2 years. The data will be from bridge, from the engine control room, and we do some preliminary baseline assessment first of all going forward. And the based on the base analysis, we calibrate our machine learning and artificial intelligence tools with this. And those tools are specific to that vessel because it cannot be generalized. So in this case,
How will how will owners and operators be ensured that their data is secure and not accessible to the competition or other companies who are sharing the same platform?
Yeah, just before actually answering, we have that part of ROI from the last question actually.
Yes,
So
that's
here,
right.
means this complete data, digitalization process, life cycle of data. It starts with the collection of data, ends to the decision making. So this is not a short-term process. Like it's not like 1 day or 1 month process. It requires considerable time. Just like IMO has taken the approach, started collecting data in 2019, and it is going to take a final decision in 2026. So there is a span of 5 to 7 years. So, but I assure that this our digital platform is definitely cost effective compared to the other platforms.
Sure.
Okay.